Estimation of hardness of water by EDTA complexometric method. Aim of the experiment. Aim to estimate the hardness of water by EDTA complexometric method. Apparatus required: standard flask, pipette, burette, conical flask, bakers. Chemicals required: 0.01 m standard MgSO4 solution, EDTA solution, ammonia buffer solution, hard water sample. Indicator: erythrome black tea or EBT. Endpoint: the endpoint is noted when the color of the solution changes from wine red to blue color. Principle: the hardness of water is due to the presence of salts of Ca2 plus and Mg2 plus. The amount of Ca2 plus and Mg2 plus is estimated by complexometric method using ethylene diamine tetraacetic acid EDTA. The basic structure of the EDTA. This is the basic structure of the EDTA. EDTA forms complexes with metal ions like Ca2 plus, Mg2 plus, Ba2 plus, and Sr2 plus in aqueous solution. Complexometric titration is the titration of metal ion with a reagent, usually EDTA, which forms clated complex with a metal. The common indicator used is erythrome black tea indicator EBT. At the end point, the color changes from red to blue. EDTA forms colorless stable complex with Ca2 plus and Mg2 plus ions present in water at a pH 9 to 10. To maintain pH of the solution at 9 to 10, NH4OH, NH4Cl buffer solution is used. Erythrome black tea or EBT is used as an indicator. The hard water, when treated with EBT in the presence of buffer solution, forms unstable wine red color complex with Ca2 plus and Mg2 plus ions present in the water. Procedure. Step 1. Standardization of EDTA solution. Pipette out 20 ml of standard MgSO4 solution into a well cleaned conical flask. Add 5 ml of buffer solution and 1 to 2 drops of EBT indicator. The solution turns to wine red color. Then it is treated against EDTA solution until wine red color changes to blue color. This is taken as endpoint. Titrations are repeated until two successively concurrent values are obtained.
So today we are going to discuss about the first experiment, that is estimation of hardness of water by complexometric method. This is also called as EDTA method because of EDTA forms complex with different metal ions at a different pH. In this experiment we required apparatus. This is called burette, conical flask, measuring cylinder, beaker and measuring cylinder. Okay. Coming to the chemicals, EDTA solution and buffer solution. To maintaining the pH, we are adding buffer solution. In this experiment, we should maintain the pH that is 9 to 10. And standard solution, at any solution we have to take, but in this experiment here we have to take MgSO4. To identifying the end point, we are adding EBT indicator. EBT stands for areochrome black tea, which is in black color. Next, coming to the principle. When the hard water means it contains dissolved calcium and magnesium salts. Hard water means, that is why here we have to take tap water. So these hard water contain dissolved calcium and magnesium salts. When this hard water is treated with EBT indicator, only we are adding 2 to 3 drops only. Immediately we are getting wine red color complex. When this wine red color complex, we have to titrate it against with EDTA solution. EDTA solution is taken in the burette. So always in this experiment, the EDTA solution is taken in the burette. Like this, we have to fill the burette. While doing the titration, at the end point, the wine red color turns into the blue color. When we are observing the blue color, immediately we will stop our titration. This is about the principle. Here the procedure involved in 2 steps. First step is standardization of EDTA solution. Here we have to take 20 ml MgSO4 solution into a beaker. So this is 20 ml MgSO4 solution. And add 5 ml buffer solution. Here to maintaining the pH, we are adding buffer solution. It is the combination of ammonium chloride and ammonium hydroxide. In this experiment, we should maintain the pH 9 to 10. So this is 5 ml buffer solution. And 2 to 3 drops of EBT indicator. Only we are adding 2 to 3 drops of EBT only. When we are adding buffer and EBT to the MgSO4, immediately we are getting wine red color complex. When this wine red color complex, we have to titrate it against with EDTA solution. EDTA solution is taken in the burette. While doing the titration, at the end point, the wine red color turns into the blue color. So here we are getting blue color. Like this, we have to do the titration. So now we are getting blue color. So when we are observing the blue color, immediately we will stop our titration and note down the burette reading. So here starts from 0, we are getting 21. Take 2 similar readings we have to take. Means in the second step also we are taking 20 ml MgSO4, 5 ml buffer and 2 to 3 drops of EBT indicator. So in the second step also similarly we are getting 21 is the reading. That only our experiment is correct. So in these values we have to substitute that formula, that is M1 V1 is equal to M2 V2. M1 is equal to molarity of MgSO4, that is standard solution, that is why the molarity of MgSO4 is 0.01. And V1 is equal to volume of MgSO4, already we know we are taking 20 ml, that is why V1 is equal to 20. V2 is always burette reading, means where we are getting blue.
As Take the values in the table as shown figure, serial number, volume of the MgSO4 solution in ml, burette readings in ml, initial reading. Normally initial reading is at 0 and final reading what we are observed in the experiment. And based on the difference between initial value and final value, we will find out the value of EDTA rundown in ml. Tabulating the values we are found in the first trial, we obtained the value of initial value is 0 and final value is 21, and corresponding the value of EDTA rundown in ml is 21. Similarly, by concurrently we are doing the experiment twice. We are getting the same values, initial value and the final values are same, and the volume of EDTA rundown is 21 ml. Of total hardness, M1 indicates molarity of standard MgSO4 solution, which is 0.01 m, where m indicates moles per liter. V1 is the volume of the standard MgSO4 solution, and V2 is the volume of EDTA rundown what we are obtained during the experiment, and M2 is the molarity of EDTA solution. Value of M1 is 0.01 m moles per liter. V1 is the volume of standard MgSO4 solution, which is 20 ml. V2 is the volume of EDTA rundown, which is 21 ml obtained from the experiment. From this, we are finding the value of molarity of EDTA solution. M2 equals to M1 V1 by V2. By substituting the values, we can obtain the value of M2 is 0.0095 m moles per liter, which is the molarity of EDTA solution. In step 2 is determination of total hardness of sample hard water. Pipette out 20 ml of tap water into a well cleaned conical flask. Add 5 ml of buffer solution and 2 to 3 drops of EBT indicator to it and stir the solution. The color of resulting solution is wine red. This is titrated against EDTA solution from the burette until the color of the solution changes from wine red to blue. This is the end point. Repeat the titration until two successively concurrent values are obtained.
In the next step, we are going to discuss about estimation of total hardness. So in this experiment, instead of MgSO4 solution, we have to take 20 ml of tap water solution. So this is about 20 ml tap water. Okay. So take 20 ml tap water into a conical flask. Then add 5 ml buffer solution. Already we know to maintaining the pH we are adding buffer solution. In this experiment we should maintain the pH 9 to 10. It is the combination of ammonium chloride and ammonium hydroxide, and add 2 to 3 drops of EBT indicator. So to identify the end point we are adding EBT. It is black color. So EBT stands for areochrome black tea. So when we are adding buffer and EBT to the water sample, Again we are getting winded color complex. These winded color complex again we have to titrate it against with EDTA solution. So while doing the titration like this, here also at the end point the winded color turns into the blue color. Like this we have to do the titration. But step by step we have to add. So when we are adding EDTA solution to the sample, immediately we are getting blue color. So this is the blue color. So here also when we are observing the blue color, immediately we will stop our titration and note down the burette reading. So in this step we are getting the reading 11. So here formula is M2V2 is equal to M3V3. So M2 means molarity of EDTA, that is already calculated in the first step. V2 is always burette reading. In this step we are getting the reading that is 11, and V3 is equal to volume of water sample. Already we know in this step we are taking 20 ml of water sample, that is why V3 is equal to 20. So that is why M2, V2 and V3 we know, based on that M3 is equal to M2 V2 by V3. So here we are getting molarity of tap water sample. But our aim is estimation of total hardness, that is why total hardness of water sample equal to M3 into 100 into 1000. 100 is the equivalent weight of CaCO3. Because of CaCO3 molecular weight is 100, which is easy for calculation, that's what we are choosing CaCO3 molecular weight, that is why M3 into 100 into 1000. When we are substituting M3 100 into 1000, we are getting total hardness of the water sample.
By substituting values in the table column, the initial value of burette reading is 0 and the final value of burette reading is 11 for each and every trial. In the first trial, the value of burette reading is initial value is 0 and final value is 11. Therefore, the value of EDTA rundown is 11 ml. In the second trial also, the initial value is 0 and the final value is 11, and the volume of EDTA rundown is 11 ml. And the third trial also, the value of initial value is 0 and the final value is 11, and the volume of EDTA rundown is 11 ml. Now by substituting the values, you can find out the molarity of the tap water by using the formula M2 equals to M2V2 equals to M3V3, where M2 is the molarity of EDTA solution, which is 0.01 m, and V2 is the volume of EDTA rundown, which is 11 ml, and M3 is the molarity of tap water we need to find out, and the value of V3 is volume of the tap water, which is 20 ml. By substituting the values, the value of M3 equals to M2V2 by V3. Therefore, M3 is equals to 0.0052 m 522 m. The total hardness of the tap water is M3 into 100 into 1000 ppm, which is equals to 522 ppm. Result: the amount of total hardness of the given sample water is 522 ppm. Thank you for watching. Please subscribe if you like.